Hello and welcome back to the course on machine learning. Today we're talking about the intuition behind the a priori algorithm. So let's get started. And we're going to get started by talking about a story. It's a somewhat legend of data science, or a legend that is quite well known in data science. And you may have heard of this legend. It's not a myth. It actually happened, but as you know, things, when they happen a long time ago and then time passes, and the facts get distorted. But I'll tell you my story of this legend, and it might not be exactly correct, but this is how I know about it and how I've heard about it. So what do you think the commonality is between these two products? Pampers or diapers and beer. What do you think they have in common, and why are they part of this urban legend? Now, why are they part of this data science legend? Well, as the story goes, a company, we're not going to name the company, but a company that is actually like a convenience store, did some analytics around the products that people are purchasing. And so they were looking at, what people are checking out with, what are the commonalities, and they analyzed thousands and thousands and thousands of transactions. So thousands of people who actually checked out, if not tens of thousands. And they found a very interesting thing that very often during certain times of the day, when people shop in the afternoon between like 6 and 9 p.m., people who buy diapers also buy beer. And it was like out of the blue, completely out of the blue. Why these two products are completely not connected, right? Why would somebody buy beer when they're buying diapers, or why buy diapers when they're buying beer, right? So that was the fact that they came across in the data. And the explanation to this fact, one of the plausible explanations, is that in the afternoons or in the evenings, when the husband gets home, and they're the husband and the wife are taking care of their baby, they sometimes find that they run out of diapers. And who has to go pick up the diapers? Well, the husband has to go pick up the diapers, right? Or the wife sends the husband to go pick up the diapers. And while he's picking up the diapers, because it's already after hours, after work, he's already in the convenience store, he also picks up some beer, right? And so that is a plausible explanation. Might be the case, might not be the case, but it sounds pretty reasonable. And based on that, so that's something that you can't really think of just by yourself, but that comes from the data, right? And based on that, you can decide how to arrange products in your store, right? So some stores might decide to put these two products closer to entice people to buy a beer when they're buying diapers. But actually, a lot of stores do the opposite. There are a lot of stores separate beer and diapers, right? Just like they try to separate, and you'll probably notice this from your convenience store, that they try to separate bread and milk as far as possible. Why? Because that way, they already know that these two products are bought together, and so you actually have to walk through the whole store to pick up, you've picked up your bread, and then to get to the milk, you have to get all the way through the whole store to the completely opposite corner of the store. So as you're walking through the store, you see more other products, and you're more likely to pick up an additional item that you weren't actually planning on buying when you got to the store in the first place. So there's a lot of interesting marketing tactics that are used based on this data, but the question is, how do you get to this data? And one of the ways to get to it is the a priori algorithm. So let's talk about a priori in a bit more detail now. All right, so a priori is about people who bought something, also bought something else, or who watched something, also watched something else, or who did something, also did something else. So it analyzes, and this whole association rule learning part of the course is all about analyzing when things come in pairs or in triplicates or not in sequence, but they are combined together for some reason, looking for those rules and those ways that this happens. All right, so let's have a look. for instance, movie recommendation, right? So you've got your user IDs, you've got movies that the people liked, movie 1, 2, 3, 4, movie 1 and 2 for the second person, and so on. And from here, just by looking at it, even without not knowing anything about association rule learning or the a priori algorithm, you can already tell that there are some potential rules that can come out of this. That, for instance, everybody who watches movie 1, not everybody, but it is likely that people who watch movie 1 will, or who like movie 1, will also like movie number 2. And people who like movie number 2 are quite likely to also like movie number 4. And people who like movie number 1 are also quite likely to like movie number 3. So there you can come up with lots of different potential rules, but some are going to be stronger, some are going to be weaker. And we want to find the very strong ones in order to build our business decisions or our other decisions on those rules that we can see in the data, right? We don't have to go and ask people, hey, do you like movie number 1 and would you like movie number 2? Because of that, do you like movie number 2? Or what is your taste and preference? We can see these things from the data, and we want to extract this information. And as long as we have a large enough sample size, if it's not just like 5 people, if it's 50,000 or 500,000 people that we're analyzing, we can come up with some quite solid rules. All right, so here's another example where we've got a market basket. So example of people who buy grocery, not just groceries, but this is more kind of like a restaurant or a takeaway place. And here you can see there's a link, obviously, between burgers and French fries, interesting vegetables and fruits, people trying to be healthy, burgers, French fries, and ketchup. So again, these are potential rules, not necessarily the ones that we're going to take away from data. This is just an example of something that you might observe visually just by looking at this data set. All right, so how does the a priori algorithm work? Well, the a priori algorithm has 3 parts to it. It has got the support, the confidence, and the lift. So we're going to start off with the support. And you will see that it's very similar to something we've already discussed. It's very similar to the way we talked about the intuition for the Bayesian, for the naive Bayes classifiers. So let's have a look here. We've got movie recommendations. Support for movie M is the number is defined as the number of users who watched movie M divided by the total number of users, right? And market basket optimization, the same thing, number of transactions containing a certain item, I, divided by the total number of transactions. Let's have a look at an illustration. Here we've got 100 people, so we've got 5 rows and 20 columns of human beings. Let's see how many of them, let's say we're talking about a movie, and I'm going to give an example of one of my favorite movies, Ex Machina. And if you haven't seen it, definitely check it out. It's all about AI and machine learning. So let's see how many of these people have actually seen Ex Machina. So there we go. There's 10 people who have seen Ex Machina, right, out of 100. So what does that mean? That means our support here is 10%. Good. Okay. Now let's move on to step 2. Step 2 is we need to find the confidence. What is the confidence? Well, confidence is defined as the number, let's go for movies. So the number of people who have seen movies M1 and M2 divided by the number of people who have seen movie M1. So here we're going to assume that we're testing a rule. We're testing a rule that, let's say, people who have seen Interstellar, right? We have a hypothesis that says that people who have seen Interstellar, they are also, or have liked Interstellar, are also likely to like Ex Machina, or let's even go with seen. People who have seen Interstellar are also likely to have seen Ex Machina. So basically here, movie number 1, M1, is going to be the Interstellar movie. The one that we're saying, okay, so we're going to take everybody who's seen Interstellar and we're going to check how many of them have seen Ex Machina. And that's exactly what we're doing here. And market basket optimization, same thing. You can think of an example of French fries and burgers. For instance, people have had burgers, who have ordered burgers, also likely to order French fries. So at the top, you'd have people who have ordered burgers and French fries. And at the bottom, you'd have people who have ordered burgers only. who have ordered burgers, regardless of whether they've ordered French fries or not. Much easier to talk about this with an illustration. Let's say those green people colored in green are the ones who have seen Interstellar, right? Who have watched this movie. Now we want to know, not out of a whole population, but out of just those people who have seen Interstellar, how many of them have seen Ex Machina? So out of them, we have 7 people who have also seen Ex Machina. So there's only 7 people who have seen both movies. That's what we're after. And so our confidence is going to be 7 divided by 40. Just by definition, this is how it's calculated. 40 people have seen Interstellar, and 7 people out of those 40 have actually also seen Ex Machina. So the confidence here is 17.5%. Good. And the next part, or the third and last step, is the lift. And what is a lift? Lift is very simple. Again, is going to be very similar to what we had in the naive Bayesian classifiers. In that algorithm when we were discussing it. So the lift is basically the confidence divided by the support. So what we calculated in step 2 divided by what we calculated in step 1. And let's just talk about it in the illustration because it's going to make way more sense that way. So here's our population. Those people in green are the ones who have seen Interstellar. And all of these people in red are the ones who have seen Ex Machina. So basically our lift is, all right, so if we just randomly suggest to a person to watch Ex Machina, right? What is the likelihood that they will, that it's a movie for them? It's a movie that, not in this population, like out of this population, we know that out of 100 people, only 10 actually watch Ex Machina, and we're going to assume that watched and like are interchangeable terms here. So we're going to assume that if they didn't watch it, they're not going to like it anyway. So if we take another random population, and then what is the likelihood that if we recommend to a random person in that population, that brand new population, we recommend that the Ex Machina movie, what is the likelihood that they will like it? Well, the likelihood is 10%, right? Because we only, out of 100 people, only 10 of them actually liked that movie. But now the question is, can we improve that result by using some prior knowledge? That's why the algorithm is called Apriori. In that new population, let's only recommend Ex Machina to people who have already seen Interstellar, so people who are marked as green in this population. So we'll only ask, have you seen Interstellar? If they have, then we'll recommend Ex Machina. What is the likelihood that a person will actually like Ex Machina if we recommend them that way? Well, in that case, the likelihood, as we've calculated, out of the green people, out of the green people, 17.5% actually liked Ex Machina. So the lift is the improvement in your prediction. So your original prediction is 10%, right? If you just randomly take a person out of your new population and recommend them Ex Machina, they'll like it with a likelihood of 10%. If you first ask the question, have you seen and liked Interstellar? If they say yes, and then you recommend Ex Machina, the likelihood of a successful recommendation there is 17.5%. So the lift is, by definition, 1.75. There we go. That is what the lift is defined as. And that's pretty much the whole a priori algorithm. That's the steps that it involves. And now we're just going to put it all together in this one kind of step-by-step process. So step 1, you need to set up a minimum support and confidence, right? So you might want to only, because there's so many different recommendations, right? We only looked at one example, one specific example to simplify things. We talked about Ex Machina and Interstellar, but as you could see in the examples before that, you could have like 100 different movies, and the different combinations, like a priori, is actually quite a slow algorithm because it just goes through all of these different algorithms, all of these different combinations. So it says, what if movie 1 is a good recommendation for movie 2, or movie 1 means a person will like movie 2, movie 1 means a person will like movie 3, and movie 1, movie 4, and then it actually combines more. It says movie 1 and movie 2 might mean that person will like movie 3, and so on. So it actually combines lots and lots and lots of, not just pairs, not triplets, like it combines 4, 5, 6, 7 items in one set, and so on. And yeah, so it gets quite big, and therefore you need to set some kind of limitations. So you need to set a minimum support. For instance, you might not want to look at products that have a support of less than 20%. You might not even want to consider them because you don't want to waste your time building a model for something that is only has a success rate of 20% on its own, right? So, or you might limit it at 5%. Then you might want to also limit a confidence. So in our example, the confidence was 17.5%, right? That somebody who liked one movie will like the other one. Maybe you might want to limit it at anything less than 12%. You don't want to look at it because it's not a strong enough factor for you. It's not a strong enough rule for you, because there is going to be so many different rules on the output of this algorithm. You already know that you'll have much stronger ones, so you don't want to consider anything that's less than 12% or 20% or whatever percentage you decide to set for yourself in that specific scenario. Then once you've set those, then you take all the subsets in transactions having higher support than the minimum support, take all the rules of the subset having higher confidence than minimum confidence, basically apply those two minimums that you've set. And then at the end, of course, you sort the rules by the decreasing lift. So that's where the lift comes in. The rule with the highest lift, given these criteria, is going to be the strongest rule, and that's the one you might want to look into first, right? Something like, I don't know, if a person buys a burger and French fries, then they're likely to buy tomato sauce or ketchup as well. Because, and that sometimes it makes sense, right? Because you need ketchup too. A lot of people like to eat ketchup with their burgers and French fries. So basically you find the ones with the highest lift, and those are the ones in your top 10 or top 5. And those are the ones that you consider for actually implementing a business decision and basing it on them. So that's pretty much how the a priori algorithm works. It was quite a long tutorial, but I thought we had some good fun here. There's another example that I wanted to share with you. Oh, okay. So just wanted to mention that recommender systems, like things like companies like Amazon use and others, and Netflix and so on, they're like they would be a good example for using a priori. A priori would be good there, but of course they are much more sophisticated. They're not just a priori. They actually use combinations or very specific or specifically designed algorithms. So I just don't want you to be confused that a priori, that means that everything uses a priori. A priori is just a basic kind of a straightforward approach to solving this problem, and it's a good example of how it can be done. But of course there are other ways of doing it, and for instance we'll look at some other methods, and in fact some of the methods that we already used can be used to build recommender systems as well. All right, so on that note, thank you for your attention, and off we go to Hadelin to look at how we can code a priori in R and Python, and I'll see you here next time. Until then, happy analyzing.